So let's start off pretty simple. This is Chapter 3, Section 1, Basic Identities. And all identities are used for is to transform something that looks ugly, usually, transfer something that looks ugly into something that looks nice. In calculus, there's other reasons to take things that look nice and make them actually look ugly because they're easier to work with. So this just allows you to manipulate trigonometry into things that make more sense for you. Kind of like the mountain problem. I forced you all to do it with cotangent, but you could have done it with tangent. So if you did it with tangent, you did it with cotangent, your answers actually look a little different. But just because they look different didn't mean they were right or wrong. They were both exactly the same. So, looking different? Is okay. I always have to warn people about this because everything's going to look different. And if you ever get into math that has trigonometry built into the problems, the book might have one answer and you come up with another one, and the two answers are literally identical, but they just look different. And a lot of people don't like that. So let's start off with the basics. Reciprocal. What are the reciprocal identities? Well, you should know these. If you see cosecant of x, what can I replace it with?
1 over sine.
1 over sine. Those are equivalent, though they look different, but that's their definition. Secant of x?
1 over cosine.
1 over cosine. What's it look like? Cotangent of x?
1 over tangent x.
1 over tangent of x. Now generally, for this chapter, generally you want to change things into sines and cosines. And that way it forces your line of reasoning to go in one direction. But that's just generally, it's not an all the time type thing. Others that we might look at is we can replace tangent of x with, what's the definition of tangent on a unit circle?
Y over x.
Y over x. And y is equal to?
Cosine. No, sine.
Which one?
Sine.
Sine. So this would be sine of x over the x-coordinate, which is normally cosine. So we can replace tangent with sine of x over cosine of x. That's a legal replacement. And similarly, of course, cotangent can be replaced with, well, if it's 1 over tangent, what do I do with sine over cosine? Cosine over sine. Just flips it. What?
I said O.
Oh. Other ones. We also have identities that look like this. Why does this identity work? Where did I pull it out of? What does it look like? It looks like a Pythagorean. It's actually called a Pythagorean identity. But where did it come from? No? It's something I taught you in
Inaudible.
previous chapter. Previous chapter. Something squared plus something squared equals 1.
Some kind of triangle.
Nope, it's better than no triangle. The first thing I taught you about trig. Draw the picture.
I said the unit circle.
Oh, did you say unit circle? I didn't hear
I
you.
mumbled it because I didn't know if it was working.
Alright, so it's a unit circle. And if this is the angle theta, what is the coordinate of this point according to sine and cosine?
Which point?
Coordinate of this point according to cosine and sine.
Isn't it x, y?
Well, it's xy, but in terms of the theta, and this radius being 1. Unit circle definition, trigonometry. The x-coordinate is?
Cosine.
Cosine of?
Sine. Oh, theta.
Theta. and sine of theta. And the equation of this circle is x squared plus y squared is equal to 1, because it's a unit circle. So if I take the x coordinate and substitute it in here, you get cosine theta all squared plus sine of theta for the y all squared is equal to 1. So far so good? All I do is take the x and the y and substitute them in cosine theta, sine theta.
But let's do, because that's sine squared.
Right, now this is technically what this means. Parentheses with a square on the outside. But the shorthand notation for it is cosine, put the square here, theta. But technically you can't square a function, you're squaring the entire answer. It's just shorthand notation. And then this one becomes sine, you put the square here, theta is equal to 1.
Okay.
But what it really means is parentheses, you
Yeah.
find cosine theta and you take the answer and
Yeah.
square.
It's different, is it?
Yeah, it's just a little different looking. So this is Pythagorean identity. It is the most used one out of all of them. The Pythagorean identity pops up all the time, and actually you look for it. Now there are two other Pythagorean identities. For instance, if I take sine squared x plus cosine squared x equal to 1, and I choose, just for the fun of it, to divide everybody by cosine squared. What do I get? Well, what's sine squared divided by cosine squared? Well, that's the same thing as writing it as sine over cosine all squared, which is tangent squared. So that becomes tangent squared. What's cosine squared divided by cosine squared? 1. What's 1 divided by cosine squared?
1 over cosine squared.
Well, what is it? Without a fraction. Secant. So you get this trig identity. Pythagorean identity. Tangent squared plus 1 is equal to secant squared. So if I saw tangent squared plus 1 someplace, I can turn around and replace it with secant squared. If I saw secant squared minus 1,
Tangent.
I can replace it with tangent squared. If I saw 1 minus cosine squared, I'd replace it with sine squared. Now be careful, it has to be squared. It can't be sine plus cosine is equal to 1. That doesn't work. Alright, what if I went back to the beginning? Sine squared x plus cosine squared x is equal to 1. What else can I divide through by?
No, wait.
If I divide by tangent, it makes kind of a mess. But I divided this by cosine,
Sine divided by sine.
divided by sine. So if I divide by sine squared, all the way across, what's sine squared over sine squared? 1. What's cosine squared over sine squared? Cotangent squared. And 1 over sine squared? Cosecant. And that gives us our third Pythagorean identity. Now the one you have to memorize is the sine squared plus cosine squared equals 1. The other two you can derive. It's really easy, divide by sine squared, divide by cosine squared. So the one you want to memorize is this guy up here, because I do not give it to you on the test. I give you a ton of formulas for this test. That's not one of them though. And none of these over here are either. These you all have to know. The reciprocals and tangents relationship to sine and cosine. Alright. A couple other identities that you might want to know. Simple ones that we'll use later. If you have an angle, call this theta, and this is the coordinate a comma b, and I go this direction. Same reference angle. What's the measure of the angle though? What is it? Mumbler? Mumbler?
Negative.
Negative. So this would be negative theta. And the coordinate of this point would be?
A negative B.
A negative b. Now, if the length of these radii are 1, we're on a unit circle. So a and b would be, 1/2 square root of 3 over 2, that type of coordinate, that when you put it into the Pythagorean identity, it'll always equal 1. So what is the sine of theta equal to? Sine of positive theta.
B.
It's equal to b. And the sine of negative theta is equal to negative b. So if I use this as a substitution, sine of negative theta equals negative b, and replace b with sine of theta, you get sine of the negative angle is equal to negative sine of the positive angle. Gives you a negative identity, I guess is the best way to say it. So if you're taking sine of a negative angle, you can change it to sine of a positive angle. You just have to make sure you put in a negative in front of it. All right, what do you think happens with cosine? Well, what's cosine of theta? A. What's cosine of negative theta? It's also equal to A. So we get this identity. Cosine of the negative angle is equal to cosine of the positive angle. So if I ever ask you to find the cosine of negative 30 degrees, you can always just find the cosine of positive 30 degrees. And it doesn't change the answer at all. Those come in handy in the next section. So what am I going to ask you to do with all this stuff? That's where the fun begins. Some work. You verify identities. For the most part, this whole chapter is verify identities. You will find that the back of the book does not have very many answers for this section. Why? Because the answer is in front of you. It actually shows you what the answer is. For instance, if I want to verify, sine of x times cotangent of x is equal to cosine of x, the answer is right in front of me. In other words, how do I make the left-hand side look like cosine of x? So if I can get the left-hand side to look like cosine of x, I'm done. Does it look like cosine of x? No. So your trick is this. Usually, if you get stuck, change everything into sines and cosines. One thing you cannot do is move pieces from the left to the right or vice versa. This is not an equation. This is an identity. So basically, you draw a line and you cannot cross it.
That's a really weird
Huh?
line. You drew it all like diagonally.
Did I?
Yes.
Oh, that's horrible. It looks perfectly straight from right here.
Oh, okay.
So whatever you do on this side, you cannot move it over to this side. Whatever you do on this side, you cannot move it over to the other side. But you can work both sides if you want to. And if they show up being exactly equal, you're done. That is kind of crooked. So what can I do to the left-hand side? Usually you pick the ugly, messier side and try to make it look like the neater side.
You can change cotangent.
You can change cotangent. So this becomes sine of x times, what's cotangent?
Cosine over sine.
Cosine over sine. And what happens is,
The sines cross out.
the sines will go away and you're left with cosine of x, which is exactly the same as the other side. That's it. That's all there is to this whole thing. Do you think I'll have that question on the test?
No.
That was so
It's gonna be
hard.
so much.
Exactly. It was way too easy.
No, that was hard. I didn't follow that at all.
Oh, didn't follow that at all. You just want me to give you better questions like this one. Sine of x over 1 minus cosine squared of x is equal to cosecant of x. This one's not bad either.
Okay.
I'll tell you when they get bad. So, your goal here is to take the left-hand side, convert it into cosecant of x. So what can I do to the left-hand side to make it look, well, better?
You can start by drawing a line like you did.
Oh, fine.
Still not straight.
Dang it.
It's better. It's better.
It's better. So, what can I do to the left-hand side?
Well,
Is there anything that looks similar to something we did earlier?
That 1 minus
Yeah.
cosine squared.
That 1 minus cosine squared. What's the Pythagorean identity?
Sine squared.
Sine squared plus cosine squared is equal to 1. But that's 1 minus cosine squared.
So
It's
it's,
equal to
the bottom part is equal to sine squared.
Yeah, if you subtract cosine squared on both sides, you get 1 minus cosine squared is equal to
Sine.
sine squared. So where I see 1 minus cosine squared, I can replace it with
Sine squared.
sine squared. Legal substitution. All right,
I'm just gonna
now,
leave with 1 over sine,
which is 1 over sine of x.
which is equal to cosec of x.
Are you sure?
I don't know.
Are you guessing?
I'm guessing.
I could tell. You're hoping.
Right?
And I've seen people do that. They go, oh, I got this. It must equal that. And sometimes that's wrong. So you got to be careful. What's 1 over sine equal to?
Cosecant.
It is equal to cosecant. And therefore you are done. But you were guessing. I knew you were. That's the sadder part.
You always guess.
But I had it right.
Yes, I know, but you always guess.
But it's still right.
But you can't magically go, yes, it's equal to this, because there might be a few steps in between.
Maybe I did know it. You didn't know?
No, because you already said you did. So I knew.
It's the Fiji water.
Maybe I was lying, but I guess.
Yeah, I'll lie about this. I know everything.
Does it get worse? How about this one? Notice how I start this off. It starts off real nice and easy. I'll tell you when a test question is going to come. This is definitely a possibility. 1 minus sine of x over cosine of x minus cosine of x over 1 minus sine of x. And this should turn out to be -2 tangent of x.
I don't like that.
But this is the type I love.
Okay, I know the first thing you do.
Okay, go for it.
You draw the line.
Fine.
You draw a picture.
You draw
Draw a picture.
Draw a picture. That's the other chapter.
Yeah.
Okay.
Next thing I can do.
Would you find the common denominator?
Why?
Because you have an equation on the left hand.
This is not an equation.
Well,
You cannot move. You cannot multiply both sides by the same thing.
Well,
It's not an equation, so don't even look at it. You can't go
is
beyond
it
that.
1 minus sine of x? Wait, no, it's not.
so
I have
you
a
wouldn't.
But I agree with the common denominator, but why? The thing is to look at.
Because you're trying to get things to cancel out.
No, not
I have a
necessarily.
question.
Go for it.
I'm sure you probably explained it before and I
Maybe.
didn't listen.
Probably.
Why is it not an equation if it still has an equal sign?
There are two different types of equal signs. Identities, the things that you use to substitute, and things you're trying to solve. Here, if you tried to solve it, all you'd end up with is x equals x.
Yeah.
So it's not something you're trying to solve. You're saying,
If you're simple.
if I see this mess on a piece of paper, I can replace it with that little bitty mess.
Okay.
That's the whole goal. You're not trying to solve for x. Because if you do, you just get x equals x.
So when you give us a problem like that, how would you word it for us to know that we're not?
Verify the identity.
You're gonna say verify?
It says verify the identity.
Okay.
Not solve for x. That'll be the end of this chapter.
Oh.
You're solving for the x itself.
Okay, if we solve for x, then x will equal x.
Yes. This one, though, if you have an identity, x equals x, you're done. Happy. Yeah. All right, now the reason you need a common denominator. How many terms are on the left-hand side?
2.
How many terms are on the right-hand side?
1.
And if I'm going to make this look like the right-hand side, I have to take the two terms and shove them together as
Oh, okay.
a single term. So how do I get a common denominator going on the left-hand side?
Wait, what?
How do I get a common denominator for the left-hand side so I can add the fractions?
What's all those?
I what? So this side is missing 1 minus sine x. This side is missing
Cosine.
cosine x.
Complicated my life.
So yeah, it makes it messy. So if I put 1 minus sine of x in the bottom, you have to put it in the top. Make sure to put both of them in parentheses because it's a binomial. All right, what's missing on that side is cosine of x. So if I put it in the top and the bottom over here, I get something that looks like that.
Which is what?
Now, once you get a common denominator, like over here it was 15, you only have to write it
As
One.
one time. So I'm going to write cosine x times 1 minus sine of x. What goes in the top? That's the fun part. A bunch of words. What's 1 minus sine of x times 1 minus sine of x? I might need a longer line.
Yeah, 1 minus 2 sine of x plus
1
sine of x
minus
squared,
2
plus sine squared of x.
sine of x plus what?
Sine squared of x.
Sine squared x.
Oh, no.
1 minus sine x times 1 minus sine x. First,
When you multiply negatives, you get a pause.
well, 1 times 1 is 1. 1 times negative sine x is negative sine x. Negative sine x times 1 is another negative sine x, so you get negative 2 sine x.
Okay.
Negative sine times negative sine is positive sine squared x. Yeah, negative times a negative is positive. Big thing here is the minus. Next to it is going to be cosine x times cosine x is cosine squared x. So far, so good?
Possible.
I'm
Sure.
gonna tell you what I'm gonna mess
Sure.
up.
Where are you going to mess up
I'm
at?
gonna square those
Foiling?
x's.
Huh?
I'm gonna end up squaring those x's.
Why would you square
I
the
don't
x's?
know, but I guarantee that's what I'm gonna do.
If anything,
If you end up doing that, just go take the parentheses off and
if you have this times this,
shove the square over the x, like the cow or the
I
moon.
know,
if you're going to write it anyway, at least put the square outside the parentheses.
okay.
You can't touch the x. All right, what can I do to the top to make it look more like the side? Now remember, tangent is sine over cosine. So what we really want to happen is probably change everything into sines up top. So how do I change everything into sines? Well,
Well, you can get rid of.
The 1 minus the cosine square is.
Yeah, you can get rid of.
oh, I didn't even look at that. That's a good idea.
Oh.
I was going to do it the longer way, but yeah, if you take this 1
1 minus
and
cosine
attach it to this minus cosine squared, that turns into
sine squared.
sine squared. So it becomes negative 2 sine of x
Smart.
plus sine
Would
squared
it be
of
2
x
sine squared?
minus, well, actually that becomes plus sine squared of x.
So it's really 2
Hold on,
sines.
let me just get it down. Cosine x, 1 minus sine of x. I know you don't like writing anything down. Would you take a picture? Okay, so that's actually a good idea. If you didn't, I would have changed cosine squared x into 1 minus sine squared, distribute the negative, and the ones would eventually cancel, but either way works. All right, so I have 2 sine squared x minus 2 sine x on the top. Minus 2 sine x plus 2 sine squared over cosine of x, 1 minus sine of x. Now what can you do?
That way.
Don't know.
No, please, keep going with that idea.
Uh,
Factor out
The sine.
and
The x,
and
the square. I don't know.
a sine, a
Two
2.
for the x.
You can't factor out the x. Sine will carry the x with it. Sine of x. I can factor out what kind of 2?
A negative
The
3.
Negative 2. So kick out negative 2. Sine of x is also kicked out. What's left behind?
A negative sign. On
Sure, it's the back end, but what's in the front end?
A 1.
A 1. Negative 2 sine of x divided by negative 2 sine of x is 1. Minus sine of x over cosine of x. 1 minus sine of x.
Wouldn't the top one cancel out the bottom one?
Now it's all multiplication. You're talking about the 1 minus sine x?
Yes.
Yep, they go away. What's left?
That is equal to negative 2 tangent of x.
Sine over cosine is tangent, so this is definitely negative 2 tangent of x.
See, I knew what you mean.
And that is exactly what we were looking for.
I didn't guess that time.
No, that one I knew you didn't guess. Because you were confident about it instead of being guessing about it. That's the type I give on the test.
Bring a whole notebook.
It takes up a lot of space of writing, if you would actually write them down so you'd have examples to look at later when you're doing your homework. Emphasis on just only 2 people in this room. Ah, that was that. I took up the entire page of my notes.
Yeah, here we go.
Oh, wait. You're both going?
no,
Well,
I'm staying.
Yeah, we fixed the car.
I fix it.
No,
You fix it.
I'm the one that looked at the video to see what to do next, right?
YouTube is so good for
Or
everything.
YouTube was awesome.
Why not? Tangent of A times tangent of B over tangent of A plus tangent of B. And I want to see if that's equal to 1 over cotangent A plus cotangent B. By the way, the mountain problem, your answer kind of turned out looking like this one on the right-hand side. If you did it with tangents, it would have ended up looking like the left-hand side. And you'll see why I didn't want you to do tangents, because you actually had to do 4 tangents rather than just 2 cotangents. Much nicer. All right, so how do I force one side to look like the other? Which side do you want to work with? It really doesn't matter. Pick a side. Left, right?
I don't really do that.
Left.
You want to do left? Most people go for the uglier looking side. Personally, I would have went with the right, but that's just me. So, let's go with the left. What can I do to the left-hand side to start forcing it to look like the right-hand side? There's the easy way and the hard way. I'll let you choose whichever way you want to go.
You gonna multiply by themselves?
You invert.
Can't invert it.
Oh.
Because if you have 1 over 2 plus 3, that's not the same as 2 plus 3 over 1.
Oh yeah.
And I mean, if you flip both sides, it'd probably work, but I'm not sure about that.
That would be unnecessary.
It'd be different. But what's another thing I could try? If all else fails, change everything into sines and cosines. But that turns out to be the hard way.
Yeah, it's not.
But that's the way most people are going to do it. So what's tangent of A turn into? Sine of A over cosine of A times, and then this would be sine of B over cosine of B over sine of A cosine of A plus sine of B over cosine of B.
And it looks messier than it should.
Well, yeah, when you change things all into sines and cosines, it'll generally make it look horrible. But sometimes that's the only way your brain's going to work. Is like, I don't know what to do, change everything to sine and cosine.
We do the same on the other side?
Don't touch the other side.
Oh, that's right.
I mean, you can if all else fails, but I try to stay away from it.
Okay.
How do you simplify that ugly expression? Does anybody have a name for that ugly expression? When you have fractions inside of fractions? Oh, boy.
Algebra.
It's algebra. If you have 2 over x over 1 over x minus 1 plus 1,
There's a name for it. And,
how do you simplify it?
You multiply by x minus
And
1. And what?
x.
X and X.
The common denominator here is x and x minus 1. What's the common denominator here?
Cosine A, cosine B.
Cosine A, cosine B. So you take the entire top and you multiply by cosine A, cosine B. Oh, by the way, it's called a complex fraction. Complex fraction. And then take the bottom and also multiply it by cosine A, cosine B. By doing that, you're not changing the value because you're multiplying by a big fancy 1. Because, cosine A over cosine B will cancel. All right, now do I distribute the top one? Or do I just multiply? Now remember I said this turns into algebra. You have to be careful how you say things. Does it distribute? If I have 2 times x times 3, does the 3 distribute to the 2 and the x?
No.
No.
No, it just multiplies, right?
Mm-hmm.
So what happens to the cosine A, cosine B?
They're
You distribute.
There's no distribution. Plus sign is necessary for distribution, or
Yeah,
minus sign is
multiply.
necessary. You're just multiplying. So basically what you can do is take this fraction bar and
Go right across.
go right across, and it's all multiplication.
Mm-hmm.
Because when you multiply fractions, you go straight across the top, straight across the bottom. What happens to the cosine A, cosine B? If I have 4 over 3 times 2, and I multiply by 3 times 2, what happens to the 3 times 2? They turn into a big fat 1. They cancel. Because it's all multiplication, all division, it just cancels out. So what's left in the top? Sine A times sine B. I purposely put the dot there to mess up with your minds, because sometimes they'll put it there. So the top is sine of A times, sine of B over. Now, does the bottom one distribute?
Yes.
Yes, because it has a plus sign. So cosine A times cosine B times that fraction there will leave you with what? I don't think this is taking us anywhere, but that's okay. I like going in circles. So what happens? The cosine A's are going to go poof. And you're left with sine A and cosine B. So sine A, cosine B plus, when I distribute it to the second fraction, what happens?
You get sine B over cosine.
Not
sine
over.
B cosine.
Times cosine of A.
Yeah.
Does that get us closer to our goal?
A little bit.
Little bit. So how do I generate a cotangent? Because obviously I'm not getting there just by changing everything into sines and cosines. So what is cotangent equal to?
Sine over cos.
Sine over cosine or cosine over sine?
Cosine over sine.
Cosine over sine. So if I could get this to be cosine of B over sine of B, and over here cosine of A over sine of B, I would be kind of happy. So how could I create a cosine over sine here? What can I divide by? Maybe that's not working. Divide this one.
Did you divide by the sine A that's, oh no, you divide by cosine B that's, okay.
Multiply by these two. If I multiply by these two, I get the one that I want. See, I could have done that at the very beginning. Divide everything by tan A and tan B, created that one, and the cotangents would have popped out. But
Why do you tell us this?
because you said sine and cosine, so I want the sine and cosine. Because you're going to do that too. You're going to get stuck in a loop. So your goal here is, I need this thing to equal 1. Need. Don't have it. So the only way I can force that thing to equal 1 is to divide by that. So I'm going to rewrite it as, this is going to be kind of messy, sine of A, sine of B, divided by, over, sine of A, cosine of B, plus sine of B, cosine of A, and I'm going to divide both of those by the numerator there. So sine of A, sine of B, sine of A, sine of B, sine of A, oops, sine of A, sine of B. So divide everybody by that numerator. So sometimes the other side gives you clues on what you really should do. You see a 1 there, and if you can manipulate it so it forces it to be a 1, that sometimes helps. All right, so what's the top become? I'll go this direction. 1. The bottom here, the sine of A is going to cancel, and you're left with cosine of B over sine of B, better known as cotangent of B. The second, this fraction here, the sine of B's are going to cancel, and you're left with cosine of A over sine of A, which is cotangent of A, which is, if you were to flip the addition on the bottom, the exact same.
Yeah.
That is also a good test question. But you could have simplified it by just dividing by tan A, tan B. That would have made this, the tan A's would cancel, you'd be left with 1 over tan B, which is the same thing as cotangent of B. And then this would have been 1 over tan A, which is cotangent of A. So if you look at these right, sometimes there's quick ways, other times there's not so quick ways. And that, I think, is the hardest part about this section. Because most of you are going to choose the hard way to do it, but sometimes you'll want to slow down and try to think your way through it before you start look at the other side and see if it gives you any clues. For instance, it's nice and warm in here. Oh, looking like you're cold or something.
It's like 19 degrees outside.
Ah, it's beautiful.
Oh, that's great. You live in New York.
Yeah. But I haven't been there in years, so if I actually had to go outside and stay there, then yeah, it's cold. Not like when I was a kid and go outside in my shirt and shorts and t-shirt. In this weather, my mom used to get so mad at me. So, here's an identity. It looks kind of weird though, if you think about it. It looks like you're flipping the fraction and changing a sign. That's it. And in essence, that's really what this identity is about. What's nice about it is fractions on the left are kind of hard to deal with. You can't separate them really nicely. But the fraction on the right is easily to separate. This is 1 over cosine minus tangent. So you can think of this as secant minus tangent. Is another way of looking at it. Okay, so what side do you want to work on? And technically it really doesn't matter which one you start with. Pick one. Right, left. Oh, we're going to go right. Let's go right for once. Right side. So we're going to ignore that side completely for a little bit, except for one thing. The left-hand side is my goal. So if this is my goal, what do I need? Well, I need a 1 plus sine of x in the bottom, and in the bottom of my working side is cosine. I need a cosine in the top, and in the top I have 1 minus sine. So you can't flip fractions. That's illegal. 1 over 2 is not the same as 2 over 1. But the goal is, I need a 1 plus sine in the bottom. That's actually the harder part than the cosine in the top. So if I need a 1 plus sine in the bottom, guess what? Put it there. Can I put 1 plus sine in the bottom? Yeah, just put it there. So, 1 plus sine. But if I put it in the bottom,
Yeah, put it in the top.
I have to put it in the top. So I have to multiply top and bottom by 1 plus sine of x. This is one of those, I see it over here. I see no way of changing cosine into 1 plus sine of x. So just throw it in and see what happens.
Yep, here goes my tip.
I know, just throw it in. What happens to the top?
The middle term will go away.
What are those two called? Do you know the fancy name?
Don't.
Begins with a C. Has a J in it.
Conjugate.
Conjugate. Conjugates. They're conjugates, so middle terms are gonna cancel out, and you're left with 1
Minus sine squares of x.
sine squares of x over cosine of x times 1 plus sine of x. Okay. What else can I do?
Change that 1 minus sine of x to cosine squares of x.
Right. 1 minus sine squared of x is the same thing as cosine squares. I like how you say that. Squares of x. All over cosine of x. 1 plus sine of x. Okay. Now what?
You're gonna be left with a cosine of x on the top.
Cancel one.
The bottom one.
Cancel one of the cosines out. And you're left with that. Which is same thing as the other side. So it's not a really, it looked horrible in the beginning, but plugging that one little idea in there brings you right to the answer nicely. Out of all the homeworks I assigned, this is probably the most important one to actually do. Because it's a technique, it's not anything but skill. Being able to manipulate these things, recognizing complex fractions, converting things, recognizing if you see a 1 minus sine squared to change it into cosine squared. If you see secant squared minus 1, change it into tangent squared, things like that. So identities, you have to open your eyes just a little bit